Good afternoon. I'm Anto Budiajo. Welcome to Monday Live. This is something that we do every Monday afternoon to try and figure out the future for smarter buildings. It's really good to have you with us today. In case you're wondering who we are, we're listed on mondaylive.org. Head over there and find out. And just a reminder that views expressed here are personal and not of any company or organization. And let's make use of that Zoom chat to make this interactive, especially since this is the last week of a month, which we tend to have a lot more interactive dialogue. And if you want anything on this deck, it's available on mondaylive.org. So this being April, we're just winding up a month talking about ontologies for buildings. It's been quite interesting, maybe not what we were all expecting, but it's been good conversation. And so today our agenda is our normal news and trend chit chat, and then we're sort of asking this question: isn't it all just semantics anyway? At the end of the day, all this ontology stuff.
Yeah.
Right. So we'll have some fun with that and see where that goes. But before we do that, I'm going to hand it over to Mr. Sinclair.
Thanks,
Going
Anto. Well, as always, lots. What happened in our backyard here is Reimagining Humanity was a TED convention in Vancouver, BC, which is, of course, is close to us. And there's a lot of insight there. I always like TED Talks. There's always good information to be extracted from them. And Kimon has basically pulled a lot of information out of that, and it supports his some of his theories that we're building our own digital twin of humanity as we start to use AI. So intriguing connections there and some good resource for the group. We have our summary of last Monday's event, Smart Buildings and AI. And we had, of course, our 5-year celebration last month, last Monday.
last week.
And get it. So anyway, that surprised me actually. I don't know if it did the audience, but it's been amazing that we've been at it that long. And I put back the C4SB semantic Tiger team kickoff because what happened is I read it the first time and I thought I understood what was going on, and then I reread it and I reread it, and I keep extracting, or there's a lot of stuff implied inside of that document. So I think it's important that we all do a reread of it. And just below that, I have that the ontologies are evolving to semantics, which obviously Anto's going to address in this particular Monday session. But this, I wasn't familiar with the resource description framework, the RDF. And so I had to go off and learn a little bit about that and find out it's not a new standard, it's an old standard. It's been around forever, and it kind of falls into the category of almost HTML. I think it's a good read if you were like me, just struggling to what that actually meant. It get as a buzzword as an RDF. It's oh yeah, another one of those annoying acronyms. But I think it's an annoying acronym that we have to understand because it's going to play a big part in what's unrolling in front of our eyes here. In addition to that, we're still supporting the Smart Building Show in the UK. They're trying to put together their program. So if you're interested in being involved in that, click on that. I've got this graphic, and the reason I threw this graphic, which is below there, a lot of what our communication is graphics. And I'm wondering how this all fits into, we have ontologies where we actually describe things, but we actually have evolved quite a bit to the fact of using pictures. When we look at a schematic like this, we now know where the boxes are. We now know where the thermal zoning is. And I'm wondering how AI decodes that and how the Tiger team is going to address the fact that part of our life is inside of graphics. So that'd be an interesting discussion, I think. And below that, we've got a seminar that's going on in the UK. And the subject matter is, I think, close to us, the of open standards in the real estate industry. And it's a free event. So anybody's around on May 15th, they might want to take that one in. And the other thing that we're starting to reach out and embrace, not that right, just get involved with more people in the industry to get our message out to a wider audience. And we're now looking at the BIM folks, and there's a lot of folks that are in the BIM industry, and it has in fact been that an information model, but the thing that has popped up here is that it's the value of all of that data that is in BIM and the ease of getting it out. And the BIM models in the past were so large and so complex that they were almost overwhelming. And actually the digital twins kind of fell into the same category. So a couple of things have happened is AI has the power to decode these things. And I think also we're all recognizing is that we have to do a better job of organizing our information so it can be pulled out in layers and pieces and stuff. And I think Kimon's been doing a lot of work in that area as well. So we're interested, and we've got a meeting tomorrow that we're talking with those folks. We're also interested in talking to the Green Build folks and a few of these other conventions that we're kind of on the edge of, and they too have the same problem as us, just getting at their data, getting it organized, and trying to make it help us create smarter buildings. Back to you, Anto.
Thank you, Ken. Next up, Rick, can you give us a bit of an update of what happened on last Friday on the Tiger team?
Sure. Another great group of people joining the Tiger team effort, and Jory and Paris too are kind of leading it towards an objective of having a narrative and also having some tools for people to be able to understand more about the different approaches to whether it's semantics or ontologies, or and we're hoping is that pretty quickly we can figure out what some C4SB working groups will be that will leverage what the artifact and the that is being created by the Tiger team. It may be as multiple chapters, but it'll also have multiple opinions of how companies and projects are defining their work, the work they're doing to create more standards around semantics and ontology. So it's taking shape to become, whether it's called a position paper, a white paper, a narrative, an artifact, there's starting to become a framework for people to be able to comment and put their thoughts in. And we think it'll also create what we've wanted to, which is the ability for these different vendors and or products to be able to define for the owner why it is that their particular approach is the best or good or less risky, or helps create better software in the long run. And by putting a little bit of, I don't know, carrot and stick, as one of the guys said, a little bit of pressure on the community to better define, that'll be good for everybody. Good for vendors, good for owners, good for people who are trying to make decisions. So that's the sort of that was my take on what happened on Friday.
Yeah, I thought it was a good call. Obviously, the group is getting to work, as it were. So we've gone through the forming and storming, and we're now norming and starting to do work. So that's great. And I think everybody's clear that this is really about human communication. It's really a project about trying to figure out how we explain things to ourselves and customers. It's not really a technical thing to do some work. So,
well, yeah, that's true. The biggest challenge is the human part, but we do intend to have some working groups that are technical that are coming out of it, is certainly as well. Yeah.
Right.
Two things can be true.
Indeed. Tracy, do you have anything to add to that?
No, no, I
Okay.
think that's a pretty good summary, actually.
Okay, cool. The link board as always. Anybody else? Any other thoughts? Anyone want to bring in? Hearing nothing, let us move on to ontologies. And isn't it all just semantics? What sort of fascinates me with innovation is that when innovation happens, people create things, and people find that they need to name those things. Otherwise, you can't actually do anything with them. Just kind of really what's going on. And because there's a lot of innovation, there's a lot of new things coming up. There's a lot of new things to be named. So in many ways, this is just the symptoms of our time because there's a lot of new stuff being created. I sometimes do this thought experiment on calls. I'll do it very quickly. Is that let's just imagine for a moment that Tracy this morning, when he got out of bed, somehow had a brainwave, and he invented, and this is a thought experiment, so it's going to be silly. He invented the wheel. He figured out something, and he says, "Oh, okay. So if you make the thing this shape, right, then it has wonderful things. It has wonderful attributes." Right. Now, imagine how he would explain that to us on this call without using the word round or circle or center or circumference or or axle or anything like that. It's really, really difficult. So you have to make up those words. And when you make up words, obviously you need to explain what they mean, and they need to relate to each other. So I don't know if that helps, but that's kind of the way I think about it. And there's different types of semantics. This is kind of just a simplification of all of that. Semantics is just the meaning of the words. Taxonomy is obviously once you start organizing them, as in dogs or canines, that is an animal, that kind of structure. And then ontology, which is what we've been talking about, which is the relationship between things. And categorization is just another way. But there are obviously many ways of sort of skinning this sort of cat, but it's an important subject that can't just sort of go away. So I'm going to stop the share and open it up for conversation.
I think the big thing, when we talked about this in between or since last week, is there's a lot more to what we're trying to promote here and move forward than just in a single ontology. There's all these other components that go into making up the overall ontology of communication here that within the buildings market that makes it understandable by humans, but also easily interpretable by something like AI. Right? Is that another way of summarizing here what we're trying to point out in this whole conversation today?
I think so. I mean, AI, I think it's interesting because it adds another sort of dimension that is very new at the same time as we're starting to having to think about these things. So it just sort of made the problem.
And once again, like in Ken's example on his opening slide when he was talking about the graphics, AI can understand graphics very well, right? It's just a series of ones and zeros and representing colors and so forth and so on. So it doesn't matter to AI, I don't think at all, if it's a graphical piece of it, but it would have to know the red spots are the hot zones, right? And once it understands that part of it, then it can interpret the rest of the graphic easily. So that is the semantic or the ontology or the the taxonomy or whatever that's necessary to make this an understandable result or outcome.
Where does that information go? How do we tell AI that the red line is something?
Into the depths of the neural net.
Oh,
Good
no.
question.
Well, it depends whether you're expecting it to look at the graph, an image, and decide that there's a red dot that does something, in which case your question is valid. But if the graphics is actually being created out of ontological sort of information graphs, then they already have all of that information.
There was a data string that went into creating that graph.
Right. That said
With
make
temperature
this.
information.
Yeah.
Right.
Yeah.
So once it creates that association, it understands.
Which is the point, right? At the end of the day, like you said, I mean, with ontologies, what we do as people is say there is a red dot, right? Or there is a round thing and we call it a wheel. That's what we call it, right? And so for what we do first is identify that there is a thing called a wheel. And then to Jim's point, we then assign it a whole bunch of metadata. What's its diameter? What's its rim size? What's its width? There's a whole, where's its center point? There's a whole bunch of metadata once we've defined that there is a thing called wheel. And with AI, we show it a picture of a wheel and go, that's a wheel. And when it goes, okay, I'm going to call it, I have these tokens, I'm going to assign it. And right, and I'll assign internal tokens. The fact that you call it a wheel is actually metadata to the AI in reality.
Yeah. And if you had an object-oriented design, those would be properties.
Yeah, right.
And then you'd have methods, wheels can do, roll, go flat or whatever. I don't know. But
But the graphic is actually always driven by code. Would it just look at the code?
It-
And sort that
I
out?
think that's an interesting point, because if it could look at the code, it wouldn't
Yes.
have to interpret the image.
Yeah,
The only reason it created the image is we humans
us.
want, yeah.
well, you've streamlined it. I mean, and that's what the model is a streamlined interface with properties or tags or whatever you want to call it, descriptive, which allows the AI to efficiently only focus on the attributes that it needs for the task at hand.
So my question, Jim, you in particular brought up this notion of semantics in our conversations. And how would you define the difference between metadata and semantics? I'm assuming semantics is a broader classification or universe than just metadata.
That's
Can
the
you
way.
elaborate
That's the
on
way
that?
that's the way I would put it. But I think that it's important for us as humans to figure out how to structure that metadata in that semantic discussion, because I think once we do, we can compel organizations, humans, others to provide that data as a base set. As I've mentioned before, Steve, if this stuff were built into the BIM models from the construction point down, and it was just built into the bid language that data had to be included, then we would all have it. And if we all agreed on what a minimum subset would be, or, as Keith said, what those properties would be, however you want to classify it, if we organized a minimum set of that, it would be greatly helpful to the controls industry in general, and probably speaking to other silos as well.
Yeah,
Cool.
and I agree completely. And I think is it fair to say that what the was the team that's what do we call them, the team, the Tiger team?
Tiger team.
Yeah, the Tiger team is part of their mission to start to define these semantic models and tags, etc. Is that part of what's going to come out of that
No.
effort?
We're going to be trying to help the different projects that are already doing that
Yep.
to better define what they are doing, and then how it compares and relates to what's happening on the other side of the fence, where the people from BIM are trying to figure out how to make their information
Yeah.
Also compatible with a similar approach. And I'm just going to throw out RDF as a common way of making graph data, I don't know, more common, more
Okay.
standardized.
So in essence, yes. I mean, the overall effort is going to facilitate, not necessarily, it's going to facilitate an already existing process, but one that now gets applied to our industry as opposed to other industries.
Our industry is
exist-
actually making its way that direction already, which is
Already?
pretty
Right.
cool. Yeah.
Okay.
But we're going to try and put a little bit of a pressure cooker. Is that the right analogy?
Yeah.
It's like bring a little light to it. And
So I think that's great. And the reason I think it's of particular importance is one of my concerns with AI is trying to discern fact from fiction. So AI has the capacity to essentially invent what it thinks is right. And if we don't take the effort to describe a wheel and all the things that we consider important to define a wheel, I don't want AI telling me what it thinks is important about a wheel.
So
Okay.
it's nuanced. So that's not a across the board valid statement. Okay. So yeah, there are types of AI like generative AI that hallucinates and that sort of thing. But descriptive AI doesn't have that problem because its ground truth is coming from history and what already worked. So it's not guessing. So when our AI is optimizing a central plan, it's not throwing out wild guesses. It's based on validated actual behavior of the system or model that is controlling.
Yeah. I appreciate, Keith, that from your point of view, the descriptive AI is going to not be subject to that. But we're talking about human beings here, applying AI in ways that they think is novel, and all of a sudden we're not sure whether what we're looking at is correct or not.
Well,
so
where
that's my concern.
The AI doesn't need the pesky humans to help it.
Right.
Yeah, it's not AI. That would be called a mechanical Turk, which is what we have, which is what we've been doing.
So Anna's off camera probably because he's talking to his AI, being nice to his AI. So
nice to the robots.
Nice to the robot. So should we talk about RDF for a bit? Because Ken was asking about this. Because it seems to be important.
Let's go to RDF.
Sorry, I had to get lunch from the front door.
So like a lot of things in this area, RDF conceptually is very, very simple. And I'm looking at you, Anno, so that if I go off script, you can kind of give me the eye. But RDF is basically a way of actually, they call them triples because everything comes in threes, right? RDF basically says something like Anno Scholten is sitting on a chair, right? That is a valid RDF statement because the way you then look at that is in code, you can replace the Anno Scholten with some code that depicts the digital representation of Anno Scholten. And instead of saying just sitting, you point that towards where the definition of sitting is defined. And there's a whole bunch of schemas that people have created to say, this is what sitting means, and this is what eating means, and this is what all the sort of actions mean, right? So Anno is known, sitting is known, and a chair is also known because a chair can also be categorized as being something that's manufactured, blah, 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 right? So RDF is just that statement encapsulated and put into, let's say, digital form. So instead of being Anno, it'll be some URL or some UUID or some code that is a representation of Anno, and the same for the other two components. So am I right, Anno?
Close enough. The thing you're describing, I just put a link in the chat. The most powerful feature of RDF is the fact that you can graph it, which is basically what you're talking about, right? I mean, that's the most powerful feature of RDF.
By joining lots of those things.
By joining the nodes together, and there's a great picture there of the Beatles, and you know, in that particular thing that describes that. So, which from a human perspective and machine perspective is one of the most powerful features of RDF, right? Which is missed by some of the other ontologies as a result. They had to work backwards, which was the missed bit in a lot of ways. But being able to draw that graph and be able to walk through that graph is the thing that you're after.
Right, then can I just sort of extend my example? So I could create another RDF statement that says that Anno is in Los Angeles. I'm assuming that's where you are right now, in Pasadena, right? So you can have those two statements in a file. So the two statements says Anno is in Pasadena and Anno is sitting on a chair, right? And you can look at that graph because there's an Anno in both of them, and actually say something like, who's sitting anywhere?
Right.
And it will say Anno is sitting on a chair in Pasadena.
Right.
So that's how, and you obviously build that up with more and more triples and more graphs, and that creates this big graph. And if you can imagine a building with that kind of graph, so you can then ask it very, very specific things about
right, which extends it beyond what we're typically used to in the BMS system, right? Which is this point is connected to this VAV box, is connected to this air handling, this connected to this chiller. But I want to be able to say, well, what rooms do they serve? You know, what's, you know, there's a whole bunch of other relationships that I'd like to add to that graph. Exactly to your point, right? Sitting on a chair and I'm Pasadena. Two potentially unrelated things, but relevant to each other, right?
So could put it in the, maybe it would be helpful to put it in the historical context compared to S or time series database. This, can you, is that fair to ask that question of like, no, compare what's now possible using RDF and graphs and query languages like, well, what's the query language? Sparkle or something?
Yeah.
Would it be helpful for people to understand that this is a new kind of way of not storing data someplace and being able to query it or being able to write code that does that query as part of the code? Am I oversimplifying it, or would that be helpful to people to understand the context of what is this advancement that we don't really understand?
I mean, in the old days, they used to call that like a component object model, like Corba and stuff like that, or, you know, an interface, right? I think.
But they don't have relationships. They don't have definitive relationships as part of their concept.
Well, correct. I mean, yeah, it's just object property models and methods, but yeah, and interface. But yeah, they
which can be used as relationships. So that sort of.
Sure. I mean, area served, the front cells, back cells, stock room. Those are properties.
Yeah, but I think just circling back to Rick's question, and yeah, you can see as an example, Rick. So let's say I've got the thermostat, but I don't have the units in there for some reason. I don't have the units come across, right? I don't have degrees C or degrees F, you know, because for whatever reason that wasn't defined. But to your point, I can look at the time series data and go like, okay, there's a thermostat and it's a space. So I'm getting numbers like 72, 73, 71. I can infer it's a degree F, you know, units on that. So by looking at the time series data, there is another dimension of, and interestingly enough, when we had just the other day, you know, I had something like a flow and I had an engine trying to do interpretation of a flow, and it was coming back with gallons per minute when it was clearly a airflow out of a VAV box, right? If it had seen the values,
yeah,
didn't have units, and if it's seen the values, it would have said, yes, okay, this is actually an airflow. type, right, and extended them. So yeah, the time series does add value. I mean that in that analysis.
Yeah, absolutely. It provides context. Yeah, it provides context. And in fact, we have a process like that. That's why we take a sample value when we're just points. I mean, for precisely that reason. So yeah, for example, we had a project in Ireland, and yeah, it was coming across as the zone temperature was coming across as 22 degrees. Okay, obviously not Fahrenheit. So yeah, the AI was able to figure out, oh, that's in Celsius.
So Michelle on chat, economical with his words, just said UML. Where does UML come into this?
Oh boy.
Anna, that was for you.
Oh, sorry. Where does UML? Sorry. Bring Michelle in. It'll probably be easier.
All right, I'll bring you in, Michelle.
We
Hang
can
on a
read
minute.
you. We can't hear you.
Here you go. You're muted, Michelle.
Can you hear me?
Yes, all good. UML.
Okay. Unified modeling language, and it was in reference to you mentioning that object-oriented methodology doesn't have relationships. So with UML, you can add relationships for object-oriented methodology or classes. And it was just a reference to your comment that there are no relationships.
Okay.
So if you use UML, you can add relationships, you can add inheritance, you can add aggregation, you can have anything, a composition, anything you want.
Yeah, in effect, that's a great point. In effect, that's a great point because that's the principle of polymorphism. So many forms.
Exactly.
And in fact, it's actually more sophisticated than just mere relationships. It's a behavior. It's in behavior encapsulation or implementation details, as you would say. So yeah, it's actually more powerful than
I'll challenge you a minute and I agree with you. I mean, that's what UML is. But don't you think that UML came in after our object model because people recognized this missing piece, right, as a result?
Yep. Yes.
So it's a little bit forced, right?
Yeah.
You don't have to do it, but it's good if you did it. But it's not inherent in the process.
It's not inherent, but when you deal with object orientation, you always assume, I mean, the base fundamental feature of object orientation is polymorphism, as Kevin suggested. So how do you represent those? You represent them with UML, and then you have aggregation. It's just modeling. I mean, if you're using RDF, I think it's similar to UML. It's just different representation of the same thing.
That is a good point too. One of the things that, again, some of the discussions we've been having any model is the important piece. You can convert models right at the end of the day. It's not, that's if you've got a model to convert to others is not a big deal, especially today that you've got. It used to be a big deal, but now not so much.
Exactly. Yes.
Yeah, XML in a sense had that capability with XSLT, transformation.
Yep.
Yeah, you guys are speaking my language now, so
yeah.
You're speaking my language.
Jim, do you have anything to chime into in this?
No, I think everybody has it covered pretty well. Nothing to add.
Okay. So again, that was a discussion on RDF.
What did we learn from all that?
I don't know. I'm going to ask you.
We have the technology. I think that's the learning, right? We have the technology.
Can be done. I'm a personal fan of RDF, to be honest. I think it's a strong.
The good thing is RDF has been around for 30 years now. And it's well known in the IT community and web services and so forth. So as far as us coexisting in those environments, that probably goes a long ways for us, right?
Yeah, and brick was based on RDF at the end of the day.
Brick.
So what is the time constant that we're looking at here for this stuff to get interesting for the industry? Let's say the Tiger team prosecutes what it's doing. Let's say that the industry comes around and the different groups that are working on ontologies and semantic models adopt RDF. What's the outcome? When do we get to see it in the field, and what's the time constant?
Great question.
Well, we talk about that a lot of like the chicken and egg is that owners will specify something that they know they can buy. Can't blame them for not specifying something that can't be bought yet. So the industry has to make it clear that there's things that can be bought that lower the risk of specifying it. I mean, again, that's the chicken and the egg part. And so that's what we're trying to get consensus, or at least common definitions, so that somebody can specify something, they know how to specify it, and they know how to ask for it. So we're trying to create some tooling and some proof that there is consistency. That will then we'll use 2525, our standards documentation method, to say, now, here, owner or specifier or engineer, here's how you will ask for it. Here's the document you will use to ask for compliance with this stake in the ground that's now been created. I think that what has happened in the history of technology and the history of industry in general is that if you can get that stake in the ground without arguing too much about where the damn stake is, how long the stake is, whatever, people will start to rally around it, and it'll happen quickly. And that, to the point that everybody has made, this isn't really a technology issue. This is a stake in the ground issue. That's my feeling on it. So we're trying to get that done so that then you can point to it and say, okay, now it's time to actually request that and to build to it. So if you're a vendor, build to it, and if you're a customer, ask for it.
So that's the point, right, Rick, is defining the it so that people can ask for, define it. You got to define the it, because people will get lost otherwise. You can't leave them up. You can't leave them to their own approach.
Define the it. I was going to say define the it and also give some cover for people using it so that it's not hugely risky.
Right. And they're really smart. People are really smart. Customers are really, really smart. We always talk about we got to do more education for the customer. They're a little bit smarter than you think they might be. They're already on to the fact that we haven't defined the it. And so that's what we're saying is like, okay, so let's go ahead and get some people together, the smartest people we can find. Thank you all for showing up, because that's really cool. Get the smartest people we can find together and just start to define what the it is, and to show proof that there is common agreement around that definition. Could be a wrong definition, could be it with two T's, who knows? But at least we'll have some consensus around what can now be requested. Now, so you remember a couple of years ago, we created this thing called 2525. And for those who don't remember what that was a place for people to specify how devices should be connected. And so we did that work first, hoping that somewhere along the line, people would come together to define the it, because we have the place where it can be bought or can be requested. It can go into common bid packages, and it can be pointed at by the owner to say, there's the it right there in 2525. And it may be not perfect, and you as a vendor may have a little bit different spin, or you want to call it this or you want to call it that, but show me how your piece maps to this stake in the ground. And I think it'll go really quickly, again, with also the air cover. Anto was saying the air cover of this being done with a community, with the governance of the Linux Foundation and C4SB, there would be some confidence that this is actually a good it.
Well, I think the Linux thing is the key to that too, right? Is that it's supported by something larger than just a group of folks.
Would love to get perspective of Tracy and Steve on this in terms of industry adoption and just general adoption.
Yeah, so I'll start by saying I think a different way to look at our problem that we're facing here with the Tiger team is not that we have a problem, we have too many solutions. And the issue is that all of these solutions were created in a vacuum to a certain degree. And now we have to figure out how to coexist with all of those solutions. I don't think any of what we already have out there is going away. It's a matter of how do we now communicate among those solutions in the end. And that will be the challenge, right? I don't think there is an it per se. There is not, we are not creating a new standard to unify the standards, right? Been there, done that. So no, that doesn't work. So I think we're trying to foster everything needed to make all these solutions communicate with one another in this whole thing. And in the end, there'll still be BACnet and Haystack and Brick and all these things will still exist. We will just know how to communicate with those moving forward, right?
Great. And I have a philosophical question. Do you think if there was an it, would we have billions of apps in iPhone and Android? There is no it. You have games, you have maps, you have bank accounts, you have anything you can imagine. And there is no RDF. There is nothing that says you cannot do anything except resources and constraints of the platform. So in my view, rather than concentrating on communications, why not communicate on a platform that allows, as Tracy said, all these different plugins communicate with each other? That was a philosophical question.
Yeah, that's a great example. You know, on the Apple platform represents a common framework that all these different app developers from all these different verticals knew how to develop to. Even though they all do different things, they solve different problems, they have different functions. Throughout them, there are still commonalities of ways to share data and information, sometimes as simple as cut and paste, or you know, my calendar talks to in my phone talks to my Outlook calendar on my laptop, or
Absolutely.
you know,
Yeah.
so they found ways to do that.
But
Exactly.
that's what the function of connection profiles is in the discussion that we've been having.
Yeah, but it's a step potentially. So there is an it. There are multiple its, one with two T's, but we're going to be able to have you describe which it you want. In the iPhone days, people forget that the iPhone was launched with no apps, zero. It was launched at a developers conference where developers, I was watching it, I'm not a developer, but I was watching it and it was developed in terms of here's the tools that you now have to develop apps. There were no apps. There was a music player and it worked as a phone.
There's a phone app.
It was a proprietary phone app. You didn't have
calendar.
access to the microphone. You didn't have access to the different functionality of the iPhone. But it was the launch of and they put a stake in the ground and said, we're taking a huge gamble. And if you remember what the price of the Apple stock was back then, it was a huge gamble. It was a massive, massive, massive gamble, putting a stake in the ground. And now it looks like, oh, well, that was really obvious. But when Avi and Steve and the team, Johnny, Ive, and everybody put that stake in the ground, there was a huge, huge risk. And it was actually done as a proprietary project. Steve knew it was going to be successful, but a bunch of the rest of us thought he was nuts. So, you know, the examples of putting a stake in the ground and then letting it evolve is that's what we're trying to do. Now, that'll also then let other folks put their model of it out there and define it.
But Yeah, and that's a great analogy, Rick. The problem, as I see it, is that Apple is a vertically integrated application or a company. So everything, they own everything, the stack, the communication. So what you're suggesting with Apple would be like the major control companies starting off, giving us access to the data and the interoperability that we need to build apps. And isn't that the catch 22? Like I'm going to make a statement here, but I really think, honestly, I kind of feel like a lot of these standards and stuff, the real goal is like it's like a backhanded goal of really trying to get to the data. And we're doing it we're being kind of sneaky with it. Okay. We're trying to develop a standard, but what we really want is the data access, right? So surely if you come out with a standard, obviously the present value is going to be one of the properties of pieces of data that we're going to. So I think we need to have an honest conversation about the industry, because until the Apples of the world give us access to the data, we're missing the fundamental ingredient that's going to make all this, that's going to power all this stuff.
Yeah, but why does it have to be Apple? We have Rick here, Linux Foundation. It's a foundation. It can be a platform for all of these things, and it's open source.
Yeah, but how are they going to get access to the proprietary building control data from the incumbents?
Through your
The same way
drivers,
that
Chief.
your platform allows you to access an app, access your location, access your contacts, access anything. We have authentication and authorization based on app and your identity. I think the fact that we have Linux Foundation here, to me, it's a platform, but again, it's a philosophical question for me.
I think maybe this is you mentioned last week, Michelle, that your focus is residential space. I think this is probably when we start to see the difference between how residential automation systems
True.
work with commercial ones, because they're just inherently much more complex.
True.
And
Yes.
proprietary.
Yep.
You don't have this problem in the industrial SCADA world. It's either TCP, Modbus TCP, or OPC. Like that's it.
But
You don't get to sell your HMI if you don't communicate with one of those de facto standards. And that's what we're missing in the commercial industry.
And that was busted up by a couple of second and third tier vendors that pushed it. And then owners started demanding it from the top. Is it three? There was top two. Yeah. It was the third player and the fourth player and the fifth player in the industry that said, screw it, let's get together and put a stake in the ground and then show owners that they should demand that interoperability.
And that stake in the ground you didn't mention is open source.
It's open source, right?
You know, to me, we're on a 30-year journey. And
Yep.
you know, BACnet has opened a lot of things up in the HVAC world, maybe some in lighting, a little bit tangentially in fire alarm. But it's largely, as we've stated on this call before, other enterprise silos or systems that politically we don't have the ability to get into. So I think these a lot of the problems are not technical problems, they're political.
Yeah.
And to Keith's point, we're using the only thing we have, which is this standards development methodology to try to overcome political hurdles.
Yeah.
Because I think that, you know, we're all very capable of getting data out of systems. It's a question of whether we're allowed to.
And technically, we are headed to a de facto standard, I think. One could argue that web services or IP is the direction all of this, that where the data needs to be made available, right? I think in the back of our minds, everybody envisions a system of the future where on browsers, we're doing IT stuff within the OT world to gather data and do that kind of a thing. So I think there is a direction to all of this. I don't know if it's the answer per se, but even connection profiles are built within the environment of the world or understanding of you know, the web and how it works and how it shares and so forth. So
I agree with that, but I bring back the topic of basically organizational behavior in customer organizations, where it's just very difficult if your customer is in a particular silo for them to even have a conversation in their own organization about getting this other data.
yeah, I didn't
Yeah.
mean I didn't mean it that you were incorrect about that.
Right.
Sure, you are correct. And the reason we develop standards is that way I can say, well, just develop to the standard, not to my way, right? It's a neutral ground for companies and groups to come together and agree, okay, we'll do it that way.
I think that the icebreaker here is applications that are compelling enough, order of magnitude improvements, or at least factors of two, that get people's greed glands going at the
Yes.
customer.
Yeah, I agree.
And that's going to be what breaks it open. And Anno, I mean, you have a lot of big company opportunities to see this at work. How do you bridge those silos, or how are those discussions had in these
Yeah.
larger organizations?
Exactly to your point at the end of the day, Jim, in that I could talk all day long about standards and protocols and platforms and sort of things. It's what is the compelling solution that you're bringing to the equation, right? And it's Excel, right? It's what's the killer app that's going to change the equation. And the same thing happened with the iPhone at the end of the day, right?
Yeah.
What was the and in fact, I think if you remember, a couple of the killer apps was just like maps, just being able to find your way around with your phone, right? As opposed to having to lug around some GPS or whatever device. So we focus heavily on that, right? It's more about what's the killer app solution, and a lot of our focus is I'm not going to build all of those. That's craziness, right?
I remember that. Speaking of maps, like that brings up I actually met the founders of a company called Keyhole. If you recall, they were the first ones to start mapping and
Yes.
stitching together different maps and stuff together. And I remember talking to the founders, and they were talking about they had no application for this. They just went out on a limb and said, we're going to spend millions of dollars stitching together different maps and integrating all that stuff together through an interface. And we think if we build it, something great's going to happen. Like they literally had no business model at all. They just went ahead and built it, and then they got acquired by, it became Bing, which became Google, and all that stuff. That was all from this little company called Keyhole.
I remember when maps and GPS first hit my handspring PDA. I thought it was world changing. I remember we were traveling, we were in Paris actually, and one of the handspring apps was which train to take to get where you needed to go to. And it was just life changing. So there is a lot to the killer app concept in this whole thing.
It was VisiCalc, by the way, Otto.
Not Excel, fair enough. Yep, good point.
And Keyhole Software is headquartered 1/4 of a mile and a quarter from me right here in Lenexa, Kansas. Yeah. And it became Bing. It became something else and then Bing, right? But killer apps, but you have to have, they have to have something to base it.
Yes, that's actually a key point, right? I mean, at the end of the day, even the apps thing, and it needed all the infrastructure and all the other bits and pieces, right? And there was an analogy that they did way back when, right? If you were to start a company to build a mapping application that you could put on a handheld device, the infrastructure alone would have killed you, right? You would never have got there. But because, I think to Keith's point, right, that you provided the infrastructure and the standard back-end piece, that you're really just bringing the solution, a new solution that's tying all those bits together. Because you couldn't do it, right? I mean, you say, okay, I'm going to put satellites around the Earth, and then I'm going to do all this technology in a handheld device, and then I'm going to have to stitch all the maps together. Oh my God! I mean, that alone would have killed any startup.
Before we lose the hour here, I've been, listening intently, trying to see where this is all headed. tell me if I'm right. Okay, so we've got a whole bunch of established standards, BACnet, BRIC, etc., right, that have been useful within the building automation world. But in many other silos, like the Autodesk world, they aren't useful. Okay, and what I'm hearing coming out of this discussion today is that through RDF, we have a means by which broadly data can be represented commonly, irrespective of what silo you're in. Okay.
Right.
And so the analogy I use is that the English language has become the default language for business worldwide. There are hundreds of languages, obviously, right, that people speak. But if you want to conduct business and you listen to whatever you listen to nowadays, you're hearing German speak English, you're hearing Chinese speak English, you hear English spoken all over the globe now, because it's become the de facto way to represent, to interact with one another. Now, is everybody who speaks English perfect? Obviously not in their, but they're able to a certain level to communicate in English if they're engaged regularly with other people. Okay, and if they want to be part of the worldwide web, if you will, of interaction. And so what I'm suggesting is that by moving in this direction of RDF, we, as an industry, we're able to go across all the silos and agree on a de facto way that all data, irrespective again of what silo you're in, needs to get represented so that all this stuff can start to work together for the first time. Yes or no?
Yes.
I mean,
Step in the right direction. Yep.
Absolutely.
Yep.
and I'm sorry I didn't interrupt.
Okay.
Yeah. We need to wrap as well. So I think this has been good. So we ended up talking about English, which is obviously all about words and semantics. So well done. Yeah, thank you, Michelle, for joining us and adding another element of intrigue. And
Thank you.
we'll get the video up sometime in the next day or so. And I hope everybody has a good week. And talk to you next week. Bye-bye all.
Thank you.
Thanks.
Bye.
Bye.
Bye-bye.
Yeah.
Bye.